Hey guys, today we're here at University of Washington to listen to Nvidia speak about their new service, GFN. We're very excited to see what they have to offer. Let's go check it out.
It's great to have you all here today. There's a lot of excitement. I hope you're excited about this, as excited as I am. I got a LinkedIn the other day, and I had a guy that was pinging me. I get a lot of emails and a lot of incoming requests. People really like what Nvidia is doing. He said, I was going to talk to you about trying to get your team to sign up with my company, but I had to stop. So I used to run Xbox 360, and now I moved over to Nvidia, now running the game platform. He said, you just have the coolest job ever. I want your job. So I'm not gonna talk about selling your company, anything. I just had to tell you. And nothing could be more true. We have a lot of fun at Nvidia, a lot of cutting edge technology. How many of you, by raise of hand, have heard of Nvidia before? Okay, keep your hands up. How many of you have heard of the GeForce Now cloud gaming software? Wow, I'm impressed. That's great. That's great. Well, we're going to talk a little bit about that. We'll get into some depth on this. We'll keep this at kind of a 100 level, but we could go deeper if you want us to. As we think about, let me just pull this over. But as we think about software, we're in this era where software is ubiquitous everywhere. And it isn't just about writing software on local devices. If you find this in your CS degrees as you're walking through and you're busy coding on your laptop or for a project or whatever else, know that a lot of times, what you're doing in that coding is preparation for what you will do in your user interfaces and also how you're building your code eventually on the server side and how that all comes together. We'll talk a little bit about that. So the agenda is really brief. We're going to talk a little bit about gaming in the cloud. Now, I have the fortune of running some of NVIDIA's game platform on the experiences side. And we do a lot around how we think about gaming, both on local PCs as well as on mobile, as well as from the cloud. We're going to talk a little bit about the future of gaming and where we're going. And in particular, how we think about some of the business things. Now, how many of you are, let me just kind of get a vote. I'd love to get participation. How many of you are in the CS degree? Everybody's hand should go up, right? But let me just ask the other question. How many of you are not in the CS degree? What are you guys in?
I'm still pre-major.
Pre-major?
Embedded.
Embedded?
Electrical.
Electrical? Isaac?
Pre-major.
What was that?
Pre-major.
Pre-major.
Data science.
Data science. We'll talk a little bit about that today. Data science. There were a couple more hands over here. Data science. I like it. You realize that MIT is spinning up a campus just for data science, right? That's pretty cool. And then there's a lot of future in this. Computers writing code. Did I miss anybody? All right. Well, we'll talk a little bit about the future of gaming. Like it or not, data science is very prevalent. It's necessary in order for us to build cloud platforms. There is no life without data science when it comes to cloud. So I'll talk a little bit about gaming in the cloud in the future. Then we're going to have Abhijit, one of the technical fellows, I should say, distinguished engineers on our team. He's going to run through the right user experience in the cloud. Believe it or not, it does mean different things when you're developing for the cloud. And then Shaikh, who's the director on my team running data science, is going to talk about delivering actionable data at scale. These are all parts of how we think about the game platform. So how do we think about this? A lot of times when I sit down with my teams, it's imperative that they understand what gaming is about, where it's going, what that ecosystem looks like, what the marketplace looks like. And this is something actually to learn as you're going through your degrees. It's often important. Well, let me ask this question. Do you think it's important to understand who your customers are? Do you think it's important to understand what the industry is doing, what your competition is? It's pretty darn important. I remember being way back in the day when I was in Windows at Microsoft, building these little architectures that my customers never ended up using. Dang it! I never used it because I thought that they were some of the best things in WDM drivers and in perf counter infrastructures that we did in Windows Core, but a lot of people didn't use it because we didn't understand, at least for that software set, who our customers were. It's imperative that you understand this. So I'm going to talk a little bit about that to do that introduction, and I'll talk a little bit about what it means to build an architecture for cloud gaming and how we think about some of the steps with that. So I don't have my clicker, so I have to keep going to the keyboard here. Let's talk about the market opportunity. Now, it's interesting to note, if you look at market opportunities, you always have to look at this with a grain of salt. Why? Because you have a lot of different companies that get paid to look at different areas, and maybe they're paid by some of the competition, but they're trying to get polls and to forecast what net effect your product is going to have in the industry. So let's talk very briefly, and I'm going to run through this really quickly. We'll come to QA toward the end of the session. So if you have questions, write them down, and feel free to ask afterwards. Let's talk a little bit about that. If you look on the right-hand side, it's interesting to note that the PC gaming market cap, $33 billion. But if you look at where it's at, you're pretty still, with maybe around 2% year-over-year growth. So you have a tremendous customer set. A lot of revenue comes in through Steam and through Battle.net, a lot of these other systems, but you're pretty still. You're pretty flat in terms of what the growth and the velocity looks like. At the bottom on the right-hand side, you look at console. How many of you own a console? Raise your hands. All right. How many of you own an Xbox? Okay. How many of you own a PlayStation? No, I ended up, when I left Xbox, I bought a PlayStation. It's actually pretty good software. I'll give it an okay, but you're all right. So in between there, you look at that, it's about $67 billion that's going in between PC and console. But console even, you're looking at the low percentages, 4% year over year. Great. So you're pretty still along those lines. Come to the other side, $70 billion in mobile. Let's think about that a second. The marketplace is shifting in this direction with the advent of 5G. Sure, 5G really hasn't come yet. A lot of telcos make a lot of noise about 5G. They're trying to get there, a lot involved in that. But you look at mobile across the world, it's become pervasive as a device, a personalized device to be used for any number of things, including gaming. Now on the gaming side, this is more your casual gamers, your Angry Birds, different casual gamers who are playing games that are specifically on the device. We're going to talk a little bit today about what that looks like in moving towards your AAA game titles or your big game titles that you can run from the cloud on your devices. So that's a brief look. In between, you've got web, you've got Farmville on Facebook, or a number of different things in web where it's generating some amount of profit, but not a whole lot. You can see this industry move. It's moving to a more mobile place. Now let me ask another question. I see a couple of MacBooks up. How many of you have Chromebooks? That's kind of interesting. I wanted to ask that question because you are up in the Microsoft area, even though you have MacBooks there. I see a couple of Windows boxes there. But we see that the prevalence of Chromebook is amazing. It's a huge growth just because of the educational system. There's a lot of high schoolers and even colleges, not necessarily UW, but colleges that are making use of Chromebook. So we know that this pervasiveness is growing. That went a little too fast. There are some fundamental shifts with that, and I'm just going to run through these really quickly. Connected devices. Talked a little bit about 5G and the ubiquity of connectivity that's happening throughout the world. Gamers, and looking at gamers being more on mobile devices and trying to move in that direction. And there's a big push towards that. Revenue. Revenue is a big driver when you start to look at moving away from buying units sold. You look at game rigs. Do any of you own any game rigs? You know what a game rig is? You build your own system. You throw in your really expensive GPU, and you've got your expensive CPU, bunch of memory, and then you play esports, right? All right. That we look at that. There's definitely a big piece to that, but we see that the revenue is shifting more to subscription models and trying to shift more in terms of entertainment and media towards streaming. This is where you look at the Netflixes and the Hulus and the new Disney service coming out November 12th. A lot of this is shifting in that direction, so the dynamics and the revenue models are changing, which means developers such as yourself that you hire onto different companies are going to have an interesting challenge ahead of you because you're going to be working on systems and core and subsystems that are going to align to delivering software to the cloud that delivers content real time. This I talked a little bit about the platforms, right, and shifting towards that platforms rather than publishers. Really haven't gotten there yet in games, right? You still have the Blizzards, you still have the Ubisofts, and even the Microsoft game studios. They're all kicking out all these AAA titles and a lot of things. And you got your AA and your indie gamers that are kicking that out as well. You will start to see the shift with the Google Stadia and the Microsoft xCloud, and especially the Nvidia GeForce Now, where that will start to change a little bit, probably a lot like entertainment and media, where content starts to come out of these services. That same side effect will happen as in entertainment. And then personalization. We're all about personalization, right? You want to ensure that the games that you play, the game saves that you have, or anything that you're doing on the internet is preserved for you between devices, no matter where you are. That's kind of where we want to go. So let's now look at GeForce Now. Some of you may have seen this before, but we thought we would play this.
Sometimes you're away from that beefy $2,000 gaming piece and you want to play some up. But that laptop of yours is definitely not up to snuff.
Game Anywhere with GeForce Now Free Beta is the easiest way to continue playing your favorite AAA and indie PC games when you're away from your gaming rig. Transform any laptop, Mac computer, or Shield TV into a GeForce-powered PC games machine.
Never actually had the chance to game on my Mac until now. This $200 Windows 10 tablet is now playing PUBG.
It was so good.
Instantly play supported games directly on your cloud gaming rig in seconds.
You don't have to worry about installing drivers.
Just log in and you can start playing like that.
Access over 200 supported games with new titles being added all the time.
Nvidia has a list of GeForce Now optimized games.
You can actually play pretty much anything that's on your personal Steam library.
You can play Ubisoft games. You've got Rainbow Six Siege. PlayerUnknown's Battlegrounds look amazing. Oh, and yes, it also supports Fortnite.
That game looks gorgeous too. Pick up your game wherever you left off with cloud saves. Seamlessly go from your rig to your laptop or Shield TV.
Grab a PC that you're using for work, install GeForce Now, and hopefully my boss never watches this video.
I just had to keep remembering the fact that I was playing this game through the cloud, which was impressive.
It's awesome.
GeForce Now. Game anywhere on PC, Mac, and Shield TV.
So we talk about cloud. That's the introduction to that. So what does it take to build a game platform? Today's world, if you look at this, you have on your gaming rig, you have your GPU, you have drivers, games that and all of the installers, everything that you're building towards that for your local gaming, right? At the top end of that, you have your content experience, hopefully through a universal launcher, if you're going through Steam or going through some other platforms. And that's how you're playing that. That's kind of gaming today. By the way, that example is not too different from consoles either, right? In the console case, you're playing locally. If you start to enter into the cloud, you get into this little thing called virtualization. Now you have to host these gaming rigs in the cloud. You have to host a number of GPUs that enable you to do things. And so there's a lot of subsystems that go into this. This is where it gets really interesting and where the developers get very interested if you look at these subcomponents. What do you have to deal with? You have to deal with things like storage. How am I going to store my game saves on that rig? And how am I going to virtualize that? What are the security containers? Right? And Barbara will talk a little bit about that. You know, people trying to crack into your system code and take over your servers. How do you schedule your resources if you've got millions of gamers that are coming against your service? What does your quality of service look like? Latency has to be, down around 100 milliseconds, unless you're going to get sick and throw up. Right? If you're playing an RPG, you need to have your latency at a very low level. And so your quality of service and how you build that in through a lot of the data science and a lot of the machinery and the development environment is super important. And then there's just the mechanics around it. When I'm running on my system, I now have to capture off of my system. right? Now I need to not only capture that, but I've got to encode it into a certain format. I've got to stream that to my client. And then I've got optimal playable settings that I might have in there, certain settings that I want to kick off automatically for my game so that I have an enjoyable experience. Because guess what? On the other side of the system, I might have a client that is a MacBook or a low-rate Windows machine, like they said on the video. So that pulls us into the applications. How do we think about running this on an Xbox controller and an Android device? How do I run it on a MacBook? How do I run it on a PC? How do I run it on a Chromebook? Any of these types of things becomes incredibly important. Your applications basically need a set of APIs that extend from that streaming to decode what has been encoded on the other side, to decode the compression, and to deliver that at a high or low latency, high performance. So you have a bunch of APIs that follow through that. That's just part of it. That's just the game seat, the gaming rig you're doing. On the other end of that, right, just because you're running a game doesn't mean that you can deliver it to millions of people. So you have a set of cloud services, and this by no means is exhaustive. But you look at cloud services such as, how do I entitle somebody to a game? How do I check with the game platforms to make sure that they're running the game and that they have authorization to run that game, right? And so I need to understand what their identity is. Obviously, if it's a service, if I need to be thinking about what my billing and payment is, how I think about my game layout, from being able to choose from different games, all the way into how I think about the voice of the customer, feedback loops and surveys and things that Bob and Abhijit will go about a little bit into more detail. And then things like user-generated content. We all like to do that. How many of you guys know what UGC is? Raise your hands. Only a couple. What's UGC? Anybody?
User-generated content.
User-generated content, which means what?
Create custom maps, custom light tracks, or whatever stuff that people put and they're going to part of it.
Yeah, so for those of you who didn't hear it, building custom maps, doing mods, right? I'm going to embellish a little bit if that's all right. It's taking screenshots and videos, stitching those together, creating montages, how you think about building, markers on your videos and in your screenshots that you can now share up to different social environments. Big thing in UGC, you see a lot of streamers out there that are doing this today, right? If you're using OBS or other streaming software with folks that are playing games and giving tips and tricks. There's a lot that goes into those services. And then lastly, how you think about AI and deep learning and what your data platform looks like. It's integral into wherever that is. It ties into your cloud services. It ties into your game seat. It ties into your clients, making sure that you have the right telemetry so that you're able to drive the right quality of service. You understand the right lifetime value of your customers. So that is basically a general architecture. It's much more complex than just installing a game on your box. Now, from here, I'll turn the time over to Abhijit, who will come up and talk a little bit about some of those experiences and what that looks like. And then Barbara will follow, and I'll close up.
All right. How is everybody feeling with the GeForce introduction? You guys like it so far? Yeah. And I think Travis mentioned we have some giveaways, game codes that can give you instant access to GeForce Now. So definitely check out after we are done with the talk. So it's great to be here amongst such a talented bunch of people. I'm super excited to kind of talk about the user experience. Now, it was extremely painful for me to condense such a broad topic into 3 slides. But my goal is, again, to give you a framework, a set of pillars, principles, or best practices that I think should be useful for you when you go back and work on the next software or the product as part of your internship or your next career. Hopefully, some of you guys land in Nvidia and work with us, but I think these are general principles that are going to be equally applicable to any product that you work on. Now, when I think about user experience, I think about 3 things. It's a combination of science, art, and intuition. And I think that makes it very interesting when you think about building a user experience. Today, we're going to talk about kind of the 3 basic principles of how you build a user experience in the cloud, especially for the gaming scenarios, and especially share some of our journey as we build GeForce Now from ground up. Now, the first one is really around thinking engagement, right? What is engagement? Why is it important? And how do you measure it? Number 2 is reach, right? How do you build a product and have unlimited reach, right? You can reach anybody in the world. And the third, and any tech talk is incomplete without a little bit of the architecture discussion, so we'll do that at the end. So let's jump right in, I believe. All right. So let's talk about engagement. So what are the, let's kind of get a poll here. What are some of the interesting apps that you guys like using day to day? Some examples?
Just shout them out. Examples.
Sorry. Netflix, okay.
Spotify.
Sorry?
Spotify.
Spotify.
Microsoft to do.
Microsoft to do. Okay. That's good. So any more examples?
Messenger, YouTube, Chrome.
Okay. So as you guys imagine, when you think about engagement, for me personally, it is the user satisfaction with using the product and the services, right? When you think about engagement, this is, we all know a highly engaged user are the ones who are going to buy the product or the service. They are also the people who are going to go and promote your service, right? People who are going to share their experiences with their friends and family. So it goes without saying is user engagement is one of the most important principles or metrics that you want to start thinking about when you're building a product, right? It is the framework that you want to keep looking into every step of the way. And when you think about user engagement, every single interaction matters, right? Whatever app you're using, every click, every thumbs up, thumbs down, every scroll is an interaction that you have with the app. So as you're building the product, you want to make sure every single interaction the user is having is optimized. It's delighting them, it's giving them the feedback that they expect to get out of it, right? Now, as an industry, there are usually 2 core metrics that people always talk about when they measure user engagement. On one side, we have what we call as NSAT, or net satisfaction. Think of it being, if you have 100 users, how many of those users are satisfied with using your product, right? So the higher the number is, the better for you. And on the other side, what we call is Net Promoter Score, or NPS. It's a measure of how many users are actually ready to promote your product, right? So a combination of 2 is always the most critical for you to keep in mind as you're building a user engagement. Now, when we think about user engagement for GeForce Now, how is it different for cloud, right? Some of the examples that you guys talked about, like for example Spotify, they have a niche where they're probably mobile only, right? But when we started building GeForce Now, our goal was we wanted to start from having this product run on a handheld mobile device to a tablet, to a desktop PC across Mac and Windows, to your big TV attached to your Shield device, right? So one of the core principles that we had to think about is how do you scale the experience across the form factors, right? From a small handheld device to a big TV. Now, the other challenge that we had to overcome was while you are building for this broad spectrum of devices and platforms, you want them to all look and feel native to the platform that they are built in, right? You don't want an iOS experience in an Android app or vice versa. So it was very important for us to think about how do you build a user experience that transparently work across these different devices, but at the same time still feel like part of the same product, right? Now, the next part of that journey that we took was understanding what are the core interactions a user would have when they're using a product, right? It's your user journey map that you start by looking at what's the first step that the user would take? Installing the product. What's the second step? Launching the product. What's the third step? Finding the games that they like playing or finding the games that they are interested in. What's the fourth step? Launching the game. And then finally, enjoy the game. So it's a simple journey that you map out to figure out what are those core steps or interactions every single user would have to go through. Now, what's the next step that you take? You instrument every single of these interactions and look at the telemetry. Look at understanding how many of these interactions are very commonly performed by the users, right? You look at what are the most repeatable tasks, because as you're building the experience, you want to optimize for the most common tasks. And what's the most common task the users would do? Any guesses? Go ahead.
Browsing and searching.
Okay. I guess the most important task is launching the game, right? That's exactly why they are there, right? So obviously they want to search and browse their content, but our goal was to make sure that the most common tasks are optimized. So then you look at your instrumentation and telemetry and continue to optimize it. And as you think about measuring these engagements and experiences, you want to build capabilities that allows the users to have a conversation with you, right? From the get-go, we invested in features through which users could give us in-app feedback that tells us what they're feeling, what their experience is. And a lot of times we think about users who are only giving us positive feedback, right? For me personally, it's any user feedback is better than nothing, right? So if users are giving us negative or constructive feedback, that still means that they're engaged. That still means that they are invested in the product. And that's still a good thing. So do not think about always getting positive feedback. Any kind of feedback is good. One of the other things that we did was to also look into end of the session, whenever the game session ended, we would have a survey so that we can map that data with the telemetry that we are seeing that Babar is going to go into details to understand not only the data part of it, but kind of overlay it with the actual experience that the users have. Now, moving on to reach, right? How do you build for reach? You start by thinking, what is your overall addressable market, right? I think Travis talked about around 2.2 billion PC users. And even if you think about a cloud gaming scenario and addressing 50% of that population, you are still in a billion users that you can reach. And what are the different ways you can break the barrier of reach, right? One of the important ways you do that is build cross-platform, right? You make sure whatever devices the users have, it's available in every device on every platform. The next thing that you do is think about localizing the product in all the possible languages so that it's easy for users to adopt, right? At this point, we are supporting around 31 different languages in GeForce Now. Then you think about globalizing the product. How do you take it to the different markets? Thinking about different content filtering, right? Different countries and regions have different rules and regulations that makes you have certain content or hide certain content. One of the interesting things that we found out as we were going for a global reach was different ratings that we had with different boards. I think some of you guys might be aware of ESRB, that is there for US, PEGI for Europe, or GRAC for Korea. And an example that I wanted to share was like with GRAC rating system, not only they wanted us to show the rating at the beginning of the game, but every hour of the gameplay. So you got to think about how do you configure your product so that you can support different languages, countries, geographies, and different rating systems. Travis is constantly prompting me to go faster. So, and then finally, how does this come together, right? Ultimately, the lines of code that you write is the reality, right? You got to choose the right technology stack and so that it can support the user engagement that you set out in the beginning and the reach that you wanted to get, right? And one of the different ways you think about it is you want to build a product that you can write once but run everywhere. But a lot of times that decision is not binary, it's not black and white. But for us, it was a long struggle because we obviously wanted to have a limited set of engineering resources and reuse everywhere. But we did not want it to compromise on quality. When you're thinking about building for such a broad set of devices and platform, one approach is to settle with the lowest common denominator. And as NVIDIA, we never didn't wanted to do that. We wanted to be the best in every platform that we wanted to support. And that's why we took a decision where we had a separate code base for Android that supports the entire Android ecosystem, but we built a separate code base that supports the desktop for Mac and Windows that can extend to the browser. So a lot of times those decisions are not going to be easy, and they're not obviously going to be binary for different scenarios that you would support. Now, a few other things that I want to touch upon in terms of a client architecture that you want to think about is the biggest problem or challenge that you have with the client architecture is it's not in your control. Something that when you're developing a client, once it's shipped, it's in the completely in user's control. So they are in complete control of it, how frequently they want to update. So you want to build mechanisms through the cloud such that you can control this client for the updates that you want to push. We thought about building ways to automatically update the client seamlessly so that the users don't have to take any actions. We also build capabilities to force update when there is a critical fix that we want to push. Another thing that you want to think about is remotely configuring the client through capabilities like your A/B testing, where you can consider different experiences that you want to run. So a lot of that thinking kind of went in as we built on the client architecture. And then finally, when you think about building that client architecture, you also want to think about the layer that will build the user experience. As I touched upon, you've got to make sure what the designers are envisioning can be translated into the code without any loss of fidelity. A lot of times you choose a platform that is not rich, but then your designers are building a lot of great experiences that you cannot translate. So a lot of these decisions obviously take time, but I think to a certain extent, it's the evolution or the journey that we went through to kind of come to a conclusion where we settled on two separate code bases, a set of common principles that allowed us to share across the different clients, and at the same time push a lot of this business on the cloud. So with that, I'll turn this over to Babar, who will continue the journey into data.
First, it's always awesome to be back on campus. I love this school, and so spending time with you guys is terrific. That said, I want to kind of address the pain point that I hear most from you computer science students. And I want to kind of tackle that because a lot of you guys are hearing references to data science. You're hearing a lot of references to telemetry. You're hearing a lot of references to qualitative data like surveys. And one of the most common questions I get from interns from UW, college hires from UW, is, Babar, how does data fit in when it comes to software development? That's the number one question I get from you kids. And really the question is, when somebody says that we built a service with data in mind from the ground up, well, what does that mean? Most of you guys are thinking Google Analytics, you're thinking telemetry data, you know, understanding reach, understanding engagement, but it's a little bit more than that. So I wanted to make a presentation that was relevant to this classroom, this school, and kind of focus on that. Now what I will do today is kind of talk about big picture. I know there are a few data science kids in the classroom. Also, I want to understand what percent of kids have already done statistics. Okay, good. Keep something in mind. What is changing when you guys graduate, what is fundamentally changing in your world? What's changing is that historically, system programming, web development, services relied heavily on what? Algebra and geometry, right? X is equal to 7, Y is equal to 3, and you have fundamentally the approach of system programming was algebra based. Now with data science, that's shifted. It's shifted to statistics. Probability becomes your key. Everything is now a probability. Another thing that's shifting on you kids. You took computer science in high school, you've done first year, second year, and what did they teach you? They taught you, hey, do a good job, spec out your code, do pseudocode, plan out how you're gonna structure your code, and then nicely and neatly write your code and test, right? But when you come into my organization in data science, that's all out the window. Because you're coming in with a mindset that is iterative in nature, right? Trial and error. There is no right answer. We're gonna go in, we're gonna construct a model, we're gonna iterate, and see which will have the highest probability of getting things right. So see what's fundamentally shifted for you kids. Gone are algebra, geometry, shifted to kind of statistics. Gone are the nice clean code and sitting there and iterating and bombarding and trying and failing and trialing and failing, and then hoping that you'll get an F1 score that makes sense. So I'm gonna stay high level. If there's interest in this room, I can do a follow-up talk with you and we're gonna go drill down and what it means in specific scenarios. My number one goal with UW kids is to hear you guys the landscape. What are the different use cases of data? And that's all I'm going to talk about today. We're going to touch on different use cases. GFN, Jensen made a remark. GFN was going to be the Nvidia service that is built with data from the ground up. So let's touch on all the different type of use cases where data is applied when building software. Okay, so we'll go one by one. And I want to kind of highlight some things that has fundamentally changed in how data was consumed by companies 5 years ago to what it is today. Number one thing that you guys should know is GDPR. Everybody knows GDPR, right? So you go to Facebook, you go to Uber, you have access to your data, the data is anonymized, you have access to delete that data, retrieve that data, you own the data. And so now when we build these systems, unlike 10 years ago, all of this has to be anonymized. So we got to make sense out of this data, and we got to make sure the data itself is actionable, that we have coverage. So we're covering, so you saw Abhijit talk about the funnel, and he talked about, hey, when the user launches the product, launches the game, we need to understand where the customer is dropping off. So we need the right coverage. The data has to be accurate. So when Daniel is actually using the product, then we got to make sure that that product itself we can understand the funnel and his click flow through the product. Where does he drop off? What are his pain points? Where does he run into errors? And lastly, we will talk about scale and performance. Our data system today has approximately 100 million users, 30 million actives, a very large population of data. So the whole system is 3 petabytes. We get about roughly 3 terabytes of data every day. So tons of data coming in. And these guys are looking at me and said, hey, Babar, this tons of data is coming from all of these users. Make this data actionable. And guess what? No longer are we in this world where we're going to summarize and aggregate this data and make it useful in 24 hours. From the point Daniel uses GFN, Abhijit wants that data within 30 seconds. So think about this, what this means. Not only when he launched the product and that click has to get to Abhijit in 30 seconds, but when Daniel comes in and says, I hate this product. I need to be able to run NLP models, extract his pain points, summarize them, cluster them with everybody else, prioritize that for him. So this is where I think a lot of the big challenges for the data team are coming. At a high level, when you think about a data platform, note this down. This is a conversation you'll have not just with Nvidia, you'll have it with Google, you'll have it with Facebook, you'll have it with Microsoft. Understand the data systems. What does it mean? At its core, you have a user profile store. We have some identifier for each of the new users. We have some sort of targeting system. And then we have a set of capabilities that sit on top. Starting from the left, we have the ability to turn on and off features. We have the ability to A/B test. So Daniel gets one experience, Fatma gets a different experience. We have the ability to get qualitative data back. So when he says to me, your product sucks, and it sucks because I can't find the game I'm looking for, how do I make that data actionable? And then you heard NSAT and NPS and all that data kind of comes in. So let's go down to specifics. Here's the common architecture of a data system. Take a picture, understand it, I'll walk you through it at a high level. So we have a set of clients on the left, right? In this case, in Nvidia, we have the cloud, we have the PC, we have mobile devices, we have the Shield TV. And all of these guys, we have 100 million set of users that are sending us events and logs. Think of events as just simple JSON payloads that are sent to us that said, he launched the app, you clicked on a gameplay, you did a search, and all of these events are pouring in. We have Kafka, which is a common messaging queue in a data platform. So all of these messages as they're coming in, they're piped down. We distill in a storage, in real-time index, we GPU parallelize. So what this means is these events are coming in, I gotta be able to aggregate them, and then I gotta make sense out of them. And so we have set of visualizations that happen, and then you see DL services, those are the deep learning or machine learning services that run on top. High level, again, when you think about a data system, you have some set of endpoints, you have a messaging queue, you have a storage component to it, you have an index component to it, you have visualization, and then you have, naturally, all of the learnings that happen right on top. Some of the systems and stats you've done, if you're familiar with R, statistical models, they'll come in, that's where you test, and a lot of your models are built on top of that data. Feel free to, by the way, in this conversation, feel free to pose any questions if you have them. How short are we on time? I know you're Travis, you're thinking. How much time do we got? Okay, how about we stay a little longer? Let's take about 10 minutes because 5 minutes won't be enough, and I want to make sure I give you guys at least the surface area of data. So here's a typical quantitative data. So we're going to talk about 3 things in this conversation. Quantitative data, qualitative data, and then machine learning, and insights. Typical dashboard of quantitative data. This is reach, number of users, number of installs, what the distribution looks like, number of active users. This is data you guys are very comfortable with. You hear it referenced all the time. Read any of the financials. They'll talk about quantitative data. Oh, here's where it gets more interesting. There's something called, after computer science, I ended up going to business school, and one of the big mysteries was, well, how did Toyota develop such a high quality car? And they used something called the Toyota quality model. And what it's based on is something called Pareto. In statistics, you cover that, what Pareto is. And notice that our systems are designed that when you run into a crash, when GFN crashes for you, and it crashes for him, those logs, those stacks are pushed up in real time. Symbols are overlaid. We, as you can see in terms of process, so here's a set of processes that are crashing. Here's a set of modules that are crashing. So no longer the debugging is the same as you guys are used to. Everything is automated. A crash happens, we diagnose which process crashed, which module crashed, and then I know who checked in what code. So notice that now the Pareto rule is very simple. It says 20% of the bugs cause 80% of the pain points. Notice that when my peers in customer experience, in design, in platform run into issues, immediately our team comes in and says, here are all your bugs, here's all your crashes, here's the Pareto, and you know where the bugs are happening, and you know how to prioritize them and how to tackle them. Use case number 2. Travis mentioned that we are a cloud service. We're compromised on the cloud. Constantly people are trying to hack us. Every day we get one major attack against our service. So the question is, how did historically this was solved before, a lot of the machine learning, data sciences, AI? How did they solve for this? Well, a lot of it was based on heuristics. I had a set of rules, right? So when Daniel logs in, if he does activity A, then he does activity B, and maybe he does activity C, hey, based on this heuristic rule, he's a high-risk person. I make a log entry, and then maybe I have some log parsers that track, hey, this activity doesn't look right. But no longer is that the world you guys are entering into. The world you're entering into is all based on anomaly detection. I have a probability model that says a user should behave in a certain way. And think back on statistics, if it's 1 standard deviation out, that behavior, or 2 standard deviations out, then it's a risk, which we call anomaly detection. So what are the degrees of anomaly? We have normal gaming, abnormal gaming, but then we have unauthorized and high risk. Notice the degrees of anomaly. Let me give you an example. Daniel comes in, and he places a mod on a game. We don't allow mods on our service, but he's not doing something that's compromising our service. So that's one degree of the problem. Another degree of the problem is he comes in, hacks the kernel, or installs an application, or FTPs to a third party, or runs a DOS using our service against the State Department. All of this happens, right? You know it happens. So our machine learning systems with nearly 90% accuracy can detect, stop in real time. Use case 2. Qualitative systems. Switch gears. We talked about quantitative, let's talk about qualitative. I get our second biggest customer base, China. Feedback is coming in Chinese. I gotta get that feedback over to Abhijit in near real time that says, here's a pain point customers in Shanghai are facing. Customers using Mac in Shanghai are facing. Historic systems, prior to this machine learning, AI, data science world, what would happen? Well, this feedback would go into a black hole. Or they would have a bunch of people sitting somewhere outside of the US farming through data and trying to make sense out of it. Or you call up IT. All of that has shifted. Now your feedback comes in through feedback surveys and forums. We have NLP systems that run. They extract. So think about what they do. They classify, they cluster, they extract, understand entities. So when Daniel says, hey, I have a problem with Call of Duty, it's crashing on your service, we have to understand crashing and we have to understand Call of Duty. Then overlaying his demographic data. Making sense? Typical NLP system. A lot of you will hear about BERT. Fundamentally has changed how NLP works today, with a level of accuracy that we can not only translate, establish sentiment, classify, and cluster data is unreal. So neural nets, fundamental background, and then you can think about sentiment, positive, negative feedback, classification, what is the problem, entity, what are they talking about, and clustering, how many people are running into this issue. The system runs by when you give us feedback to the time it's available again to Abhijit, less than 30 seconds. Okay? Here you have an example. Feedback coming in. 100,000 feedbacks coming in. All of this is happening in real time. It's actually summarizing, clustering the issues. It's showing you the trends of the issues. Last use case I want to kind of touch on, quality of service. You saw that referenced. So traditionally, let's not even talk about Nvidia, let's talk about Netflix. When Netflix serves you a video to watch, how does Netflix know that they're serving you high quality video? Natural answer from a system programmer is build a heuristic model. If frames per second are X, if stutter is less than Y, if frame loss is less than Z, then you're serving high quality experience, right? How does machine learning change that? Well, it fundamentally changes how you think about quality. At the end of each session, in a streaming session, we ask you, how was your experience? You rate us through 1 to 5, right? What have you done for me at that point? You've labeled that session for me, right? So when millions of people in active running sessions are telling me, this was a good session, and this was a bad session, immediately you think to yourself, okay, you have millions of sessions that are labeled now. What's common in what's good, and what's common in what's bad? Understand, distill those features, and then you can predict in real time what kind of quality and caliber of experience I'm providing you. See, that the barometer is no longer a dev or an engineer that used to come up with a set of rules and heuristics. The barometer is the end user. Customer satisfaction becomes your barometer. That's how you fundamentally are changing your thinking. So with that, I'm going to stop. I know I'm tight on time, and I wish I kind of, I'd love to kind of drill down into these models with you guys. And like I said, if there's interest in this room, happy to return, happy to talk about it. Cool? Awesome.
So as you heard Bobber talk about this, let me talk a little bit about the team dynamic, just to kind of summarize things up. When I look across my team, my product team, I have my user experience designers. They're all focused about how we think about reaching the customer, what are the right user experiences, interaction, and visual designers doing a lot of user research. And a lot of that is actually interesting. Bobber didn't touch on this point, but there is this movement that's happening, and it's something that I'm actually doing in my team right now. There you go. I'm giving you some insight that even my team doesn't know, where I'm starting to merge data and user experience design together. Why is that? Because this time frame that I need to get customer feedback and understand the customer lifetime value is diminishing. I need that in 30 seconds. I need real-time access to what customers are saying that feeds into my user experience, that allows me to go out and do modeling that in order for us to build the UI. So I have a set of designers who know the product, who know the industry, that are trying to design the right user experience, and now they're melding with data and trying to understand at the same time what kind of feedback is flowing through that in any of the designs that they're coming up with. That's one classification of some of my employees. Other employees, you saw Abhijit go through, I've got a great client team. Client team is trying to build software across ubiquitous devices across the board in order to deliver that customer experience that the designers are working on. And that is rough code. Right? If you think about that, it's very hard to get to a high stability when you think about reliability and performance and security, when you're deploying n number of clients across a broad ecosystem, across geographies that you don't have complete control over. You have to push remote configs like Abhijit was saying. You need to ensure you're able to update your user experience at the snap of a finger. You need to be able to ensure that you're rolling out with that. Another class of my developers are developers working in the services side. Bobber touched a little bit around that as well. Really focusing on the data, but also focusing on those core services, right? And ensuring that those services and the interfaces that are built out of those services are able to interact in real time such that the clients and the gaming can happen with a high quality of service. Then I've got my data teams who are all trying to drive this ecosystem and helping us to help build a data infrastructure that allows us to drive the right development patterns because we can learn real time about our customers. Then I've got other developers that are working on how we think about visual compute. I don't know how many of you know this, but are you familiar with the Nvidia RTX GPU that just came out? Groundbreaking. Why is it groundbreaking? Did you know that we've carved out space on that GPU for data science? Instead of doing raw compute that would be leveraged for cryptocurrency in the past or leveraged for high compute models, we are now layering in machine learning, deep learning, into the GPUs themselves that allow us to do things like real-time ray tracing. Just think about that. We're years ahead of where we thought we would be in terms of GPUs in the brute force power of how you think about visual compute. Because we're able to take those data science models, apply those onto the GPU, and now all of a sudden I get Battlefield 5, and I can see reflections coming out of mirrors or out of the water below, all through what? Machine learning, data science. This is the direction that we're taking. When we look across the teams, you know, at UW, as you're studying, as you're going through your courses, it's incredibly important, and Bobber touched on this a little bit, it's incredibly important that you reach out and think about what area are you going into? Where's going to be your focus? You might not know where you'll end up in jobs. And like you said, you know, Lauren and I would love, you know, to talk to you more in terms of Nvidia, because we've got great things going on, but you never know where you're going to land. Think about what the end destination is going to be and be observant. That it's not just about you locking yourselves in your room behind a laptop with nobody else around typing away on your keyboard and coding. It's actually very collaborative. You need to understand your customer. You need to understand in real time what your customer's doing, where your competition is going in order for you to deliver and design the right products. And that's where all of these services, whether it's Microsoft or Google or Facebook or Nvidia or Netflix or Hulu, you name it, any of these services are building along those lines in fully understanding what their customers are. Now we know that this is emerging. When we talk about game platform, this is a fun little quote from Investors Business Daily. Cloud gaming is poised to shake the video game industry. And because of that, it's because we want to understand what the customer is. When I was back at Xbox, actually, Bobber was with me at Xbox at Microsoft, so was Abhijit. We're all Microsoft as it kind of went on. But it was interesting, you know, Bobber I had asked to go and be a sponsor for Xbox One and working with a lot of our key executives at Microsoft and Xbox to ensure we're able to bring that product to bear. Guess what a lot of his work was? Figuring out what our customers want, what they hated, what they liked, what types of things could we further push to make sure that Xbox was a good product. Well, we're doing the same thing in NVIDIA, but we're doing it at the next level. It's automated. It's all through our thinking and the data models and the machine learning that we're bringing to bear. So there is a transition. We have this high-powered hardware, very efficient hardware. We're now not only able to put it in, slap it into our gaming rigs, but we can host it in the cloud. We've got ubiquitous connectivity that's coming. With the advent of 5G and 4G and Wi-Fi, all of our devices are connected, right? And now we got a lot of systems that are below spec. I can play Fortnite on the lowest spec of a PC possible, or a Chromebook, or device, or whatever the case may be, and still have a great experience. Guess what? It's more about the content now in this case, especially in the form of gaming, than it is about the software that's running. It's all about the gaming and the content experience for that. And that leads us to convenience. We know that's the big change as you think about moving into this. Now, as you go in and think about development, you might go into different spaces. You might go into the consumer market. If you go into consumer, it's all about convenience. If you go into enterprise, it's a little bit about convenience, but much more about security, stability, reliability, because you've got mission-critical systems that are running that may be life or death in some cases, depending upon what you're working on. Those are the types of things that you should be thinking about in your mindset as you are going through your classes and thinking about, okay, I'm on this project, I'm writing this code. All right, how's this code going to help me in the long run to be a better developer or a better data scientist or, in the industry that you're going into? That kind of wraps this up from here. I'll invite Lauren up. One of the things that I didn't mention before is, as part of the raffle, we're also giving away some of the GeForce Now game codes. So, depending upon the raffle, then you can get access to that limited external beta and play on that. And then we're happy to entertain questions afterwards. I think we're like 5 minutes over, so go ahead.
Can we put up the first slide by chance?
Yeah.
Hi everyone. I was at the UW fair recently for affiliates. So I met some of you. There's some familiar faces out here. But for those of you who don't know me, my name is Lauren Silvera. I'm on the university recruiting team at NVIDIA. So if any of you are interested in internship opportunities, full-time opportunities for next year, or if you're graduating in December, we might have a few there too. Feel free, if you have your resume, you can give it to me here. Or if you already checked in and entered this raffle, I'll send you an email tomorrow, so you'll have my contact information. So we'll be after if you guys have any questions. Also, if you're not interested in career opportunities, but you want to enter the raffle to get some gaming codes, you can still do that now. But I already pulled the raffle for the Jetson Nano, so hopefully they're here. Junyoung Chung?
Right here.
Oh,
that's wonderful.
Congratulations. So as for the gaming codes, for the winners for that, you'll receive them this week. So check your email, make sure your email is accurate for that raffle. And then feel free afterwards, we have some job descriptions, some beanies. Please take one each, so hopefully everyone gets one. Yeah, and we'll be here if you guys need anything. Thanks so much.